Okay. We have to get critical value approach. The homework was all about the p-value approach. Today is about critical value approach, and we can get introduced to manually calculating if the problem is giving us the sample standard deviation instead of the population. This is the formula. I'm going to read it to you because I use words to describe it. It's just like the Z1, except for it's the sample mean minus the hypothesized mean. That's our numerator, and that has to be subtracted before you divide. The sample standard deviation, there's the difference. Instead of population standard deviation, sample standard deviation divided by the square root of the sample size. You do your numerator, do your denominator, and then divide. And that will give you what's called your t-test statistic. This is no different than last week's homework, except for we have the sample standard deviation instead of the population. All right? Now, I put a bunch of examples up here. I hope this will help. These are some rules that I find that help you keep track of what you do, because we're getting to one tails and two tails. Let me show you. Look, one tail test. Here's an example where the null hypothesis says greater than or equal to 3. The alternative would be less than 3. The one below it says that the null hypothesis will be less than 3, and the alternative will be greater than 3, the opposite of the one above it. And so you say to yourself, okay, if we're given the population standard deviation, then we're going to be using norm SIMV or norm.IMV, one or the other, whichever one. What goes in here? When we were doing confidence intervals, that's just like a two-tail. The confidence plus half the significance. All right? The confidence plus half the significance goes in there if it's two-tail. If it's one-tail, only the confidence goes in the parentheses. You don't have to add half the significance. All right? Same with this week with sample standard deviation, TIMV. What goes in front of the degrees of freedom? What's the first number? If it's a two-tail, you're putting just the significance there. But if it's a one-tail, you have to put double the significance there. This is where everybody falls apart right here. I want to say that one again. You ready? If you are doing a sample standard deviation and it's a two-tail, just like a confidence interval, you put the significance there. But now we're getting into one-tails with sample standard deviations. What goes there? Instead, you have to double the significance. I know, this is crazy, isn't it? This is why you get writing them down in some kind of way that will refresh your memory when you're taking the test. The second one, there's two numbers. There is the significance, comma, degrees of freedom. Okay, I'm going to go backwards. I'm going to go back to last week's PowerPoint to talk about critical value when there's a Z involved. All right? What?
So we use
this norm.SIMV, you can use this one or the other one, but that whatever you're putting there as that first number is the same whichever one you're using. It's going to, for two tails, it's going to be that confidence plus half the significance. For one tail, it'll be just the confidence. That's if we're doing p-value. But this is going to find your critical value. This is going to find that critical Z. Are you ready? Here's some examples, matter of fact. Which one is this with? Right here. You ready? We're reading a problem, and we realize it's a two-tail problem. The significance in the problem says 5%. Because it's two-tail, 5%, we're going to follow this rule. Here we go. It's a Z problem. It's a two-tail, 5%. We use the confidence plus half significance. So the confidence for 5% is 95. Half of the significance, what's left over is 5, is 2.5. So this would be 97.5%, 95 plus 2.5. But here's an example of a one-tail. Different significance, 10%. We realize we're reading a problem that's a one-tail, and it's giving us the population standard deviation, so it's a Z. And we want to find that critical Z that we're about to talk about, and And I want to put it all together here in a minute, but we're looking for that critical Z we're about to look for, and we realize it's a one-tail. That number in the parentheses is just the confidence. We don't have to add back half the significance. So if the problem said 10% significance, the opposite would be 0.90. This is if we're trying to find critical Z. This all comes together now. Here we go. You ready? See this bell curve? In the first 3 weeks, it was all about finding the confidence interval where half is to the right, half is to the left of the middle, the mean, right? And the part that's in these tails is the significance. Last week, the p-value is comparing the tail to the significance, the tail to significance. This week, we're comparing the test statistic to what's called the critical value. And these are how you find that critical value. Now let me jump to an example so that you get this all put together here. You ready? Remember this problem about the TVs? We're calling a bunch of houses, we're saying, hey, how many TVs do you have? How many TVs do you have? And we find out this, we think that each house has about 3 TVs. We also know the population standard deviation is 0.8. So here's our null hypothesis now. Ready? The null hypothesis said the mean amount of TVs in the U.S. households is 3. The alternative would be the mean amount of TVs not in U.S. household or in U.S. households would not be equal to 3. So it's a one-tail or two-tail? One-tail or two-tail? Two. Two-tail it is, because the equals not equal to. Suppose the significance is 5% and the sample size is 100. Stop. We have the information to calculate our critical, or not our critical, we do have the information to calculate critical, but we have the information to calculate that test statistic as soon as we get that sample mean. We're now going to compare it to 3. We're now going to divide by, where's the standard deviation? 0.8 over the square root of 100. As soon as we get that sample mean, we're going to do it. But what we need now is critical Z. Is this is a two-tail, what is the positive and negative number that represents 5%? Just like when we were doing confidence intervals. All you need is that 5%. Now, we have the population standard deviation. So to find that critical Z, this is which one we're using, top or bottom? Top. Now, we also know the significance is 5%. We know this is a two-tail. Look at the rule, two-tail, 5%. What number goes there? 0.975. Oh, let me change your grade. Oh, I'm sorry, there's no extra credit. My fault. I thought there was extra credit for me. I was so excited. Thank you. Exactly. 975. We use the rule. Take the confidence plus half the significance, put it together. Exactly. And then we'll end up with, there it is, 1.960. Now, I'm going to put 1.960 negative right here. I'm going to put positive right there. There's my critical values. Here's the deal. When I calculate the test statistic Z, because it's population standard deviation, so Z, if my calculated Z is outside the critical Z's that we just found, I reject the null hypothesis. I'm going to repeat that. I'm about to calculate the test statistic Z, not T. We're heading to T. Same rule though. Everything's the same with T. I'm about to calculate the test statistic Z manually. I'm going to compare it to what we just found using norms.inv called the critical Z. Our critical Z is negative and positive 1.960. If what I calculate is outside, either it's negative above, outside of negative 1.96, or larger than positive 1.96, I'm rejecting the null hypothesis. But if it falls inside those two numbers, not outside, but inside either way, because it's a two-tail, I can't reject the null hypothesis. Here's our calculation. You ready? What is our sample mean? 2.84 minus our hypothesis mean of 3 divided by our population standard deviation of 0.8 over the square root of the sample size 100. 2.0 negative. Here we go. 1.96 negative 1.96. 2.0. Is it outside or inside? Just give me the words. Outside or inside? Outside. Can we reject or not reject? reject, because we're on the outside. If our calculation put us on the outside, we reject. That's called critical value approach. That's it. Woo, woo. We're doing another, but this time. Wait, are we doing this manually? We're doing critical value. We're going to do it manually. This time it's T. This time it's all about T. We don't have the population standard deviation. If we read it carefully, we're going to be given the sample standard deviation. A phone industry manager thinks that customers' monthly cell bills have increased and is now an average of over $52 per month customers are paying. The company wishes to test this claim. Assume, oh, look at this. This is not a T. Assume the population standard deviation is 10. We're still on Z. This is another one. Here we go. We're still on Z. Okay, don't forget now. Here we go. We got the information. Hey, you think it's going to be above 52, they're paying more? Well, then here's what happens. The null hypothesis would be the opposite of what you think the deal is. You're trying to prove that the bills have gone up, right? So the null hypothesis is that the mean is going to be less than or equal to $52. Your hypothesis, the alternative that you're trying to prove, is that the mean telephone bills will be over $52. But if you come up with 53 or 54, that may not be high enough. They have to be significantly over $52 to prove your point. Matter of fact, we're going to use, where's the significance? We got to wait for the next slide for the significance. $52 is our right side. What the average is when we get over how many we're going to, does it say how large the sample size is? We got to go another slide. Okay, but does it give us significance? No. It's going to use 10% significance. So hang on a minute. Look at our null hypothesis, alternative hypothesis. Am I using TIMV or norm SIMV for this problem? Top or bottom? Top one, because we still have population standard deviation of 10. We're using 10% significance. This is a one tail or two tail? Look at it. Look at it. What is it? One tail it is. One tail it is, because we got less than, equal, and greater than. It's not equal and not equal to. It's not two tail. It's a less than, equal, and a greater than on the alternative. Since it's one tail, all we got to put there is the confidence. 10% significance, what's going in the parentheses? 0.90, 0.90, 90%, the opposite of 10%, because it's one tail. It's not two tail. One tail, you just put in whatever the confidence is. You don't have to add half the significance. You'll then get 1.28. Where's that one there? Here it is. One tail, 10% significance. 0.90 goes in, the opposite of the 10%, because it's one tail. Confidence only. 1.282. 1.28. They just didn't put the third digit in. So now, here's the deal. Is it positive or negative? Are we looking at, oh, wait, we got to go back here. Would we use positive or negative 1.28? Remember now, look at what we're comparing. Our null hypothesis is that the mean is $52 or less. Our alternative, which is really where the test is taking place, is $52 or over $52. So our test statistic, if we're right, is going to be larger than 52, which puts it, we need to be up in here to prove our point. Up in here. So we're using the positive 1.282, not the negative. So once you get to this point, you get to that number, you got to decide which one you're using, the negative or positive, because it's a one tail. It's not a two tail. We're not using both. Because it's a one tail, are we using the positive 1.28 or the negative? We're using the positive. Here it is. Notice it's in one spot. All 10% in this tail, because it's all only a one tail. We're about, now when we find our mean of our sample, what do we subtract? The mean of our sample minus what number up there am I subtracting? The mean of our sample, if this were Z, minus the hypothesis mean, which is what? 52. Minus 52 divided by standard deviation is what? 10. Over the square root of, we don't know the sample size yet. Ready? We decided to use a sample size of 64. We collected all the data, divided by 64, we get a mean of 53.1. We do exactly what you said, 53.1 minus 52, divided by the standard deviation of 10 over the square root of 64. Our test statistic Z, because we had the population standard deviation, is 0.88. 0.88. Does anybody remember what the test statistic was? 1.28. 0.88. Are we inside or outside the critical Z? Inside. Do we reject or can't reject the null hypothesis? Can't reject. If we're on the inside, we cannot reject. We're on the inside. 0.88 is inside that 1.28. We cannot reject. That's using the critical value method. Oh my God, this is becoming easy now. Isn't it? 0.88 is inside of 1.28. Therefore, it's not sufficient evidence that the mean bill is over $52. Yes, we got, the mean was over 52, 53.1, but that's not enough evidence to prove that on average, if we had time to do all of them, that they'd be over 53. That's not enough evidence, so we didn't prove our case. We can't run to the bank with it. We didn't win the bet. P-value, we already talked about p-value. Here we go now. There's the new formula. T is going to be the test statistic. The formula is exactly the same as Z, except we're using sample standard deviation. Let's do our first one. But now to find critical value, TIMV, whatever this first number is, common degrees of freedom, you got to decide the first number based on whether it's a one-tail or two-tail. An average cost of a hotel room in New York is said to be $168. Oh, really? We're not sure that's true. We're going to check and see if the average cost of a hotel room in New York City is $168. So we went ahead and called a sample of 25 hotels, and the results were $172.50 was the average. For how many? 25 hotels. Hey, it is a little different than 168, but is it significantly different? To be able to say, no, that no way could if we had time to call all the hotels, it would be over 168 because our mean is 172.50. We don't know if that's true or not yet. Depends. What's going to be the significance involved? By the way, with those 25 hotels we called, we got a standard deviation of 15.40. That's the sample standard deviation, by the way. And we decided on this little deal that for us to prove our point that it's not $168, we're going to use 5% significance. That's pretty good significance for a business problem. This is something that isn't hugely important. Humans are not going to digest it. This is a business problem, and 5% shows it is important. So, for whatever reason, here we go. We're going to take our sample mean, 172.50 minus 168 divided by 15.4 over the square root of 25. But before we do that, we got to figure out what our critical T is that we're going to compare this to. Here, and we're using this, TIMV. How many degrees of freedom do we have in this problem? 24. Why is Haley the only one answering me? Is this on video, Haley? Oh, I'm sorry. Man, where did you keep getting jammed up on that extra credit? And is this a one-tail or two-tail?
Two-tail.
Two-tail it is. So because it's a two-tail, because it is a sample standard deviation, and our level of significance is 5%, what will be the number that goes right there in the front? 0.05. 0.05 it is. All right? All right. So I don't have this ready. Let's do it. Is this it right there? No. Put it right here. 0.05 you said, but the significance is 24, or the degrees of freedom. So our T is 2.06, what's that next digit, 4? Right here, 2.064, is that right? 2.064, and this is two-tail, so negative 2.064. Okay, here's what's going on now. We're going back to this. You ready? We're about to calculate 172.50 minus the 68 over the $15.40 divided by the square root of 25, which is 5. And we get positive 1.46. Our critical T's are 2.064. We got 1.46. It falls inside the critical T's. So can we reject or not reject?
Not reject.
Not reject it is. All right? Because we fell inside the critical T's. too easy, wasn't it? All right, you've now learned how to do critical value approach. You've already learned how to do p-value approach. You've now learned what formula to use if it's sample standard deviation instead of population standard deviation. Thursday, we're going to go into p-value again with sample standard deviations. But we have one more thing, and this kind of is a little, we'll see how it turns out. It's going to be hard, but this is called the confidence interval approach. So this is the third and last approach of how to determine whether to reject or not reject a null hypothesis. This combines what we learned in the first 3 weeks with what we're doing now with this, which is hypothesis testing. All right? So, the critical value approach says, find the critical value upper and lower interval, and then look to see if your sample mean falls within that interval. If it does, we cannot reject the null hypothesis. If it doesn't fall within the interval, then we can reject the null hypothesis. So, we're going back to the same problem here. I'm going to review it real quick. Our hotel, 25 hotel sample, got 172.50. We're going to use that to see if our hypothesized mean, not our sample mean, but our hypothesized mean, to see if it falls in our confidence interval. Pretend the 168, when we're doing confidence intervals, is not being discussed yet in confidence intervals. With hypothesis testing, we're trying to test it about 168. But let's go back to confidence interval. Our mean is 172.50, so we go 172.50, right? Plus and minus, and then it would be whatever our critical t is, t times, and it'd be the standard deviation, 15.4, over the square root of our sample size, which is 25. We would find that confidence interval by plugging that in from, just like we did from week 2. This is the same thing as week 2. We plug it in, we found our critical t by using this right here, right here, degrees of freedom, 24, and we got 2.064. 2.064 times the standard deviation 15.4. Our confidence interval goes from 178.86 to 166.14. Now, here's the step we didn't do in week 2. We go back, we look at the hypothesized mean, and we ask ourselves, does it fall within the confidence interval? If it does, you cannot reject the null hypothesis. But if the hypothesized mean is outside the confidence interval, you have evidence to reject. So look at this hypothesis mean from this slide to go right there. Equals 168, not equal to 168. We go back and look at our interval, and we say, does 168 fall between the lower and upper interval? And in this case, it does. So we do not reject the null hypothesis. The average hotel in the city could still be around 168, or 168, even though our 25 ended up at 172. All right, so here's the deal. You learned the p-value approach, you learned the critical value approach, and now the confidence interval approach. We gotta just take it to prepare for the homework. You have critical value approach on one of the problems on this week's homework. Go ahead.
Critical value approach that we did last week.
We just talked about it a little bit last week, but
So it's the same thing?
It's the same thing.
Oh.
Yeah, exact same thing. I just went more in depth in it today. I want to show you the homework. Here's the week 5 instructions, by the way. There's the homework. When's it due? October 8th, usual situation. There's the materials. There's 2 chapter 9 PowerPoints, by the way. Last week was part 1, this week's part 2. So make sure you realize there's 2 of them. And the homework, page 328, problem number 35, A and B, but listen to these directions. Show your manual calculation details to find the test statistic, that's this right here, because these are T problems. To find that T, you're using this manual equation right there, and then the Excel equation to find your critical value, that's this equation right here, TIMV, degrees of freedom, and you gotta decide whether you're putting the significance or double significance, whether it's a one tail or two tail. All right, that's what's being used, says right there, to find the critical value. Then, if you can or cannot reject the null hypothesis using the critical value approach. So that's what's happening, you're using the T, critical value approach, for that problem right there. 329, 38, A and B, you're just grabbing the information for both A and B, same with 35, but you're doing this. Show your manual calculation details to find the test statistic. Again, it's just like this again. Then use Excel to find the critical value, which is this one right here. You gotta decide if it's a one tail or two tail. Then tell whether you can or cannot reject the null hypothesis using the critical value approach. You're comparing what your test statistic is to the critical value. Is it outside or inside? Then you tell me whether to reject or not reject. What was that? That was 38. And then 41 is the last one. Just 3 of these problems, but there's A, B, and C on this one. This is the exact same thing. Here, oh, I'm sorry. This is different. This is different. This one is show your calculation details and give the Excel function equation to calculate the p-value for part B. Then answer part C about whether you can or cannot reject the null hypothesis. But you gotta use p-value in this one. This is what we're talking about mostly on Thursday, plus a few other things. Any questions?
Yeah,
Are we
Professor,
good?
You didn't post though, part 2.
Say that again?
You didn't post part 2.
I didn't post one?
Part 2?
The
Part 2.
PowerPoint.
The
You're kidding me.
Yeah, that's how.
Yeah.
Oh, I didn't open it up yet? I forgot to open it up?
Yeah.
So the whole week's module's not open? How am I gonna edit that out of this week?
Oh.
Man. All right, I will post it in a matter of a few minutes then. I'll post it before I leave. Anybody forget to sign in, please sign in.
What is one?
Wait, also?